Um, Hello everyone. Today we're gonna work on Leetcode 1562. Find the latest group of size. Um, so look at this problem. At the beginning, when I look at this problem, I don't have any idea in my mind. But if you think it in a different way, then it may help us to solve this problem. So it asks us to find the latest date on which we can find our a window with size m. Inside of the window, all the characters are 1, but the two neighbors outside of the window are 0. So we need to find the maximum, the maximum, like the latest date that we can find such a window or not. If not, then we just output -1. If we can find such a window, then we just output, we just return the latest data that we already find. So if we think of this problem in this way, it asks us to find the latest date. So it's better for us to save the date that for each of the character on which day each of the characters are on which day the character is okay. We need to find on which day the current character it's turning from 0 to 1. If we can if we have this kind of information, then it's gonna be easier for us to process. So for example, for this, let's take a look at the first example, this one. Assume we have an integer array we call days, and say it saves all the dates on which the current element is turning from 0 to 1. So for example, this one, the first step 1, it is a little bit tricky because for the day 1 or the position here are all 1 index. So let's see. On step 1, that means day 1, we change the position 3 to from 0 to 1. So position 3 is actually position 2 if it is 0 index. So let's see. This is the initial state, and then the position 3 changes from 0 to 1 on day 1. So we save 1 to this position 3. That's actually position 2. And then on day 2, we change day 2, which is 5. So that means on day 2, we change the position 5 to from 0 to 1. Position 5 means actually means position 4. So that means this one, position 4. It changes from on day 2, right? So we need to modify this to day 2. And then on day 3, it's actually we are changing day 3, changing position 1. Position 1 is actually position 0, so on day 3. Okay, and then on day 4, we're changing position 2. It's actually position 1, day 4. And then the last one is position 4. It's actually on day 5. Okay, so now we can have this integer array. It saves the dates on which the current element is changing from 0 to 1. And the ask is actually, can we find a window with size m that inside of the m, all the integers are 1, and outside of the window, the two neighbors are still 0. So what does that mean? The ask is actually, for example, let's take a look. Let's assume if m equals to 3. And then we can see this is a window that we're currently looking at. So what does that mean? 4, 1, 5. That means the 3 positions inside of the window, it's changing from 0 to 1 on day 4, day 1, on day 5. So on which day all the 3 are changing from 1 to 0, from 0 to 1, it's on day 5, right? So we need to find the maximum value, because on day 5, all the 3 inside of the window are all 1s. And what other conditions we have to meet? It's the 2 neighbors outside of the window are 0. So what does that mean? For example, in this one, what does 3 and 2 mean? Means these 2 neighbors are changing from 0 to 1 on day 3 and day 2. So on day 5, it's already been changed from 0 to 1. So that means this is not what we want. But let's assume this is 6 and this is 7. So what does it mean? In this window, inside of this window, we find the maximum is 5. And then all the 3 are 1s on day 5. And then on day 5, the left and the right neighbors are still zeros, because the smaller one, which is the left neighbor, gonna change to from 0 to 1 on day 6. So this means we can find these windows are one of our solutions, right? And what we can return from this solution. So the problem is asking us, the question is asking for the latest date. So what is the latest date? Let's see. On day 5, all the 3 are 1s. And these 2 are still 0. So day 5, it's one of our answer, right? But is it the latest date? Let's see. Let's see what happens on day 6. On day 6, it's actually, this one is changing to 1, right? So this one, after this one changing to 1, then this sliding window, or this sliding window, it's maximum. No, it's larger. The size is larger than m. So this is not our solution. It's not the solution we want. So in this case, the latest date is 5. But let's make this a little bit easier. Okay, so now we can see the 2 neighbors are 9 and 0, 9 and 8. What does it mean? At least on day 8, the red neighbor changing from 0 to 1. So on day 5, all the 3 insides are 1s and the 2 neighbors are 0s. On day 7, the 2 neighbors are still 0. And on day 6, day 7, and anything does not change, right? It's still the same. So, but on day 8, and then the red neighbor changing to 1, and then the window size is larger than what we want. So this is not the solution we want. So on day 8, no, 8 is not our latest date. The latest date is 7. So what does that mean? We need to find such a window, and then we also need to watch for the 2 neighbors. If there are 2 neighbors, the minimum of the neighbor the minimum value of the 2 neighbors must be larger than the maximum value inside of the window. And also, so in this case, we can find a solution. But what is the latest date from this solution? It's gonna be the minimum one, the minimum, or not the minimum, the smaller one of the 2 neighbors, and then minus 1, right? Okay, so now let's start coding. As we said, we need to first manipulate an integer array to save those dates. So first, we need to find the size. And then second, we need to make such a array. So we call it days. Now let's loop through this array. So what does that mean? Day equals to should be it should be I, right? But it's the I, it's 0 index, which we want to turn it to 1 index. And the position of the element, it's this one, but it's also, this one is 1 index. We need to change it to 0 index. So then in that case, we can save this to date. Okay. Now we have this integer. Okay, now next we need to it's a sliding window maximum problem. So we need to maintain a deck to save the maximum value. We need to maintain a deck to save a decrease integers into this deck, and then the first value of the deck, it's always the maximum value of the sliding window. So we need to initiate deck queue, and also we need to maintain, or we need to save our results to a variable. So if we can set it the initial value to -1, because it asks us to output -1 if we cannot find such a solution. So now we can loop through our array. In the deck, in the sliding window maximum solution, so we need to maintain a decreasing deck. So in that case, whenever we process a new element, which is I, we're gonna first make sure the current element it's smaller or larger than the last value in the last value of the deck. If it is smaller than the last value of the deck, then we just save it. If it is larger, then we need to pop out the last value of the deck until there is no more elements which is smaller than the current elements. So that's gonna do that if it is not empty. And the value of the deck, it's smaller or equal to the current value, then we just pop it out, because that value is not useful, because we only want the maximum value of the sliding window. So we just pop it out. So after pop it out, we can add our current element. And until now, can we say that our first value inside of the deck, it's the maximum value in the current sliding window? No, because we add a new element, we need to make sure our the maximum value that we maintain inside of the deck still inside of the current sliding window. So what does that mean? If it is not, then we have to pop it out too. So that's, we can also write like this. So right now our the processing index I, and our sliding window size is n. So let's say sliding window size is m. So if the q dot first, if the first element we saved in our deck, it's smaller than this current, then this value is, let's say, if 0, okay, this, then it outside of the sliding window, so I have to pop it out. After we do this, can we say that the first value of the queue is the maximum value that we want in the sliding window? No, because we have to make sure we already processed enough elements. For example, if m is 3 and we only process 2 elements, then we cannot do anything, right? There is no enough elements. So we have to make sure our current value is larger than m minus 1. Then, okay, if it is smaller than this, then we don't do anything, we just continue. So if it is larger than this, then we have enough elements, then we have the maximum value saved in the deck, and then now we can start processing it. So just as we said, now we have a lot of information. For example, we have the maximum day, we have the maximum index as from Q, right? So that means we have the maximum current max day is day index, and then this is whether this is our output. It's still decided by the two neighbors. So we have to find the minimum number of the two neighbors. So let's see. So first, let's see like the pre-neighbor index should be which one? Let's if we are at 4, and then 4 minus 3 it's 1. Okay, then this is our previous, and then post index gonna be this easy, right? And then we need to find the minimum date of the neighbor. So if we want to find the minimum date, we're gonna save, okay, maximum value, and then if pre-name index larger or equal to 0, then in days equals days, and what? Okay. Right? Okay. If post name index, then in days equals to max in days post name index. Okay, so now from the previous analysis, we say that if the minimum dates of the two, if the smaller date of the two neighbors are smaller than our max dates, then this is not the solution we want, right? So if the mean dates it's smaller or equal to our max day, then we don't do anything. But if not, then we need to make sure if it has been updated or not. If not, then that means there is no neighbor. So we can just till the max day. Else, it should be the mean day minus 1. Okay, now we can return our results. Let's see. Okay, so now this is how to solve this problem. Hope this week video can help you to understand and then solve this problem better. Thank you so much. See you next time.